Welcome. PSM 201. Study Section 1. Introduction, Fundamentals of Medical Statistics. Introduction. Statistics means different things to different people. Most times, the literary use of the term statistics refers to the numerical facts and figures about people, places, or things. For instance, health records officers collect daily or weekly statistics on patients attended to at different clinics in most hospitals. Some of the information they collect include items such as sex, distribution, age, education, etc. In this study section, you will be introduced to statistics, the rationale of statistics to health science, and some basic concepts and terminologies used in statistics. Learning outcomes of study section 1. At the end of this study section, you should be able to define statistics and biostatistics, understand why the knowledge of statistics is needed in health sciences, describe some basic statistical concepts and terminologies. Definition of statistics. As a scientific discipline, statistics deals with the scientific method of collection, organization, summarization, presentation, analysis, and interpretation of data. It could further be classified into mathematical and applied statistics. The former focuses on the development of different theories, while the latter focuses on the development and application of statistical methods to real-life problems in different fields of human endeavor. Use of statistics. Knowledge of statistics has become a critical requirement for any meaningful health research. This is reflected in the great emphasis on statistical methodology as a component of original articles published in most peer-reviewed journals in the health sciences. Many of these journals provide guidelines on statistical issues such as study designs, randomization techniques, sampling method, sample size, estimation, methods of data collection and data analysis, methods and assumptions, use of software, etc. The volume and technical nature of information provided in clinical trial reports and other evidence-based medicine literature requires some knowledge of statistics for critical review and understanding. Often, physicians, irrespective of subspecialty, are often involved in data generation, which they may need to summarize in order to present meaningful and useful information for decision making. A common feature for such data is the ever-present variation in the different data values from one patient to another. The sources of such variation include inherent biological difference, measuring instruments, environment, observers, etc. Statistics is needed to handle this inherent variation in measurements. The importance of statistics comes from its usefulness. The uses of statistics can therefore be summarized as follows. 1. Evaluation of the medical literature. 2. Applying study results to patient care. 3. Understand epidemiologic problems. 4. Using diagnostic procedures. 5. Participating in or directing research projects. 6. Decision-making and forecasting. Meanwhile, there are two broad dimensions of statistics, namely descriptive and inferential statistics. Descriptive statistics, as the name implies, has to do with the description of characteristics of a finite population. It entails the use of statistical method for presenting and summarizing data in form of table, chart, or graph, or number. On the other hand, Inferential statistics goes beyond describing the data but drawing conclusion from data. In other words, it is used to reach a conclusion about a population based on sampled information of that population. This involves estimation and hypothesis testing. Some basic terminologies. Some basic terms that will be used frequently in this course include the following. 1. Data. It generally consists of members of measurement or count of a population sample, and it provides information. For instance, when a nurse weighs a patient or takes a patient's temperature or counts the number of patients in a ward, a measurement consisting of a number such as 70 kilograms or 35 degrees centigrade or 20 patients is obtained. 2. Variable. A variable is the characteristic of interest that, if when observed, take different value at different units. It could be described as a placeholder for a data value, just as a lamp holder is to a bulb. Items such as name, age, sex, weight, height, PCV are examples of variable. This can be qualitative or quantitative, continuous or discrete. 3. Population. It refers to the total collection of entities or units in which we have interest. 4. Sample. It refers to a fractional part of the population. 5. Parameter. It is regarded as a measure obtained by using all the data values in the population. 6. Statistic. This is a measure obtained by using the data values of sample. It is important to know that a random variable can be classified into discrete or continuous random variable depending on the values it assumes. Suppose you count the number of nursing students who enrolled for this course in a section and the amount of school fees that they paid in that section. In this case, the number of nursing students is an example of a discrete random variable, and the amount of school fees they pay is an example of a continuous random variable. Summary of Studies Section 1. In this study section, you have learned that statistics deals with the scientific methods of collection, organization, summarization, presentation, analysis, and interpretation of data. It could further be classified into mathematical and applied statistics. Biostatistics is therefore a branch of applied statistics that deals with the development and application of statistical methods to solving problems in the biological sciences, health, and medicine. The importance of statistics comes from its usefulness. The uses of statistics can therefore be evaluation of the medical literature, applying study results to patient care, understand epidemiologic problem, using diagnostic procedure, participating in or directing research projects, decision making and forecasting. There are two broad dimensions of statistics, namely descriptive and inferential statistics. Now we've come to the end of the study section 1. Thanks for listening.